So let's get started today's code reading session. As we have covered till the static analysis in last code reading session, in today's session we'll be covering from the dynamic analysis. Okay, so we are reading the Indian Standard Code, which is IS 1893 Part 1, 2016, right? So this particular code is basically useful for the structural design and analysis related to the concrete RCC structures in terms of earthquake. Okay. Okay. So let's get started. So I believe everybody has opened 1893 Part 1 2016 in their system or in front of them. Okay. Please start reading from 7.7 dynamic analysis method.
So, linear dynamic analysis will be performed to obtain the design lateral force. It is the design seismic base shear and its distribution to different levels along the height of the building and to various lateral load resisting elements for all buildings other than the regular buildings lower than 15 meter in seismic zone 2.
Okay, so the whomsoever is having that question all the time, we are getting that when to analyze the dynamic analysis. Do you need to do it in all the structures? For them, this is the answer. So it needs to be done other than regular buildings lower than 15 meter in seismic zone 2 and zone 3, 4 and 5 for all the structures. Okay. Yeah, please proceed.
The analytical model for dynamic analysis of buildings with unusual configuration should be such that it adequately represents irregularities present in the building configuration. And dynamic analysis may be performed by either the time history method or the response spectrum method. When either of the method is used, the design base shear, that is VV, estimated shall not be less than the design base shear VV bar calculated using the fundamental time period TA. When VV is less than VV bar, the force response quantities, for example, the member stress resultants, story shear forces, and base reactions, shall be multiplied by VV bar by VV for earthquake shaking considered along. The two mutually perpendicular plane directions, x and y, separate multiplying factors shall be calculated, namely VV bar x by VV bar, VVx and VV bar y by VVy, respectively. And for the vertical z direction, the multiplying factor shall be taken as the maximum of the VV bar x by VVx and VV bar y by VVy.
Yeah, so it is saying basically about the scale factor. Okay. So you might have already done it quite a few times. For the vertical z direction, as we have discussed earlier in one of the sessions, that the z direction, whenever you are taking earthquake, the maximum scale factor between x and y needs to be considered. Yeah, so next person from time history method.
Time history method. Time history method shall be based on an appropriate ground motion, preferably compatible with the design acceleration spectrum and the desired range of natural periods, and shall be performed using accepted principles of earthquake structural dynamics. Then 7.7.5 responsive spectrum method. Responsive spectrum method may be performed for any building using the design acceleration spectrum specified in 6.4.2 or by a site-specific design acceleration spectrum mentioned in 6.4.7. In 7.7.5.1, natural modes of oscillation, undamped free vibration analysis of the entire building shall be performed as per stabilized method of structural dynamics using appropriate mass and elastic stiffness of the structural system to obtain natural periods Tk and mode shapes phi k of those of its n number of modes of oscillations that needs to be considered as per 7.7.5.2. Number of modes to be considered. The number of modes nm to be used in the analysis for earthquake shaking along a considered direction should be such that the sum total of modal masses of these modes considered is at least 90% of the total seismic mass. If modes with natural frequencies beyond 33 Hz are to be considered, the modal combination shall be carried out only for modes with natural frequency less than 33 Hz. The effects of modes with natural frequencies more than 33 Hz shall be included by missing mass correction procedures following stabilized principles of structural dynamics. If justified by rigorous analysis, designers may use a cutoff frequency other than 33 Hz.
Okay. So
Shall I
combination
continue?
of mode. No. Combination of modes. Somebody. So there is no such things to explain in this. This is basic, very basic things. What is time history? What is response spectrum? What are the number of modes that you need to consider? Those things are being just explained over here. Okay, so that way. Yeah, Vijayant, you can read.
Uh, Code 7.7.5.3 combination of modes. The responses of different modes considered shall be combined by one of the two methods given below. Uh, A. Peak response quantities, for example, member forces, displacement, story forces, story shears, and base reactions may be combined as per a complete quadratic combination CQC method as given below.
So
Lambda
this is
is
the so this is the
equal to
formula for finding out the peak responses through CQC method, which we are not doing. We are generally doing the SRSS method, right? We are doing the SRSS method for dynamic analysis. That also is one of the methods that you can use. But for CQC, if you do it, the backend will run this lambda formula for you, and it will give you the estimated peak response quantity. Okay, so what is the peak response that is coming amongst the all the modes? Okay, and also the CQC is an additional advantage that it gives is it talks between different modes. Let's say for an example, if certain mixed modes are coming, and if you have to take that mixed mode into the final considerations, in that case CQC is very effective because it basically calculates the coupling moments between two different modes. Okay, so the overlap issue or the coupling issue between two modes is not at all considered in SRS. That's why we say that you keep the 10% difference very, very evidently since we are using SRSS combinations. But in case of CQC combinations, even if you are not taking, it automatically calculates between two modal, changes or two mode, how it is reacting between each other. So that aspect is also being considered through CQC method. So this is little bit, I would say, higher side of this thing it will give you, because it calculates certain extra moments or extra coupling effects between the modes. But if the modal shapes are distinct by 10% of the difference of each modes, then SRSS will give you the best results because it is considering only that modal behaviors individual mode wise. So it doesn't consider any of the modes to overlap with other modes, or it is talking to other modes. It is just taking each mode and it will analyze according to those modes peak responses. So this is the basic difference between complete quadratic combination and SRSS combinations. So if you are using complete quadratic combinations for any such structures, this particular lambda value will be giving you the estimate of peak response quantity. Okay, so this is being told by many. There is a very good video for from the ANSYS developers who have developed the ANSYS softwares. They have explained it really good, this complete quadratic combination and SRSS and their differences. So it is available in the YouTube or internet. You can watch that video. In the ANSYS also, they are using the same methods, right? It is just a concept that they are using, CQC and SRSS. So how it is different between each other, as I have told, that coupling effect is not there in the SRSS, whereas in CQC it is there. So you will be getting in detail of that how the formula is getting changed between these two. They will be basically giving you a in-depth breakup of this entire formula actually, which you are seeing over here, 1 plus beta into beta to the power 1.5. All this formula they will break up and they will show you how it is being actually calculated. It's a small video, 15-20 minutes video. You can watch that. That will be very beneficial. Okay, so I don't, it is not required to read the formula back again. You can start reading from this B point. Just read out the write up part and skip it to the next write up part.
Hello, sir.
Yes.
Sir, can you please explain it once again? Why we use CQC and RSS? I don't understand, sir.
CQC is being used if you want two modes to talk between each other in a nutshell. Okay, so for an example, let's say for an example, if you are having the mode number 1, okay, mode number 1 is giving you some UX value, some UI value, some RZ value, and some other degrees of freedom are also there, right? Now mode number 2 is also give you some UX value, some UI value, some RZ value, and some other degrees of freedoms are also there, right? Now, if you want these two modes to talk between each other, and due to certain problems, if you have certain problems where this mix mode kind of a situation, you are not being able to nullify, because if it is present due to some geometric problem or due to some other problems, if this mix mode you are not being able to nullify from your project, or in any project, if the geometry is such that you need to use with this mix mode only, you can't make it a distinctive mode. Sometimes it happens due to stiffness and other issues. So if that situation is there, then you need to take the effect of this mix modes also, how it is affecting between individual modes, because that time the 10% difference will also be not there. That time there will be no distinctive UX, UI and RZ modes also will not be there. There will be different kind of overlaps between one mode and another modes. So if you are having this kind of complexity in your case, that time you can use CQC. So which will actually give you the effect of the coupling moments between these two modes, how the couple behavior is happening, right? How these two modes can work together, okay, in order to change the behavior of the structure, in order to explain the behavior of the structure. So that effect of this extra moment also it will be taking over here in under the modal case. If you make it CQC, it will give you that effect, modal case also, and that response spectrum case also. Response spectrum case is there, no, spec X and spec Y. Over there is a modal combination type where we keep it as SRSS. So this needs to be made as CQC. Okay, so this is the thing that CQC is being done. Whereas in SRSS, what it does, it's like calculate only one, means only one is there. All the forces of one mode will be taken care. Next two, next three, next four, like that individually it calculates all the modes. It doesn't calculate any coupling effect. For the SRSS, I'm saying. Because this is square root summation of square. So ultimately it will become just a single mode, whatever value it takes. So that particular single mode, it's just considers to calculate this particular result. So whenever we can be able to manage these differences, whenever we can be able to distinct our mode UX, UI, RZ and so on, then only we should use this SRSS, which you are doing in most of the projects after many trials and all these things. What will happen if you involve this CQC and if you involve this coupling moment, unnecessary, the building, that modal behavior would be little heavier, or the modal analysis would be little heavier. So that is not possible also sometimes, that is not required also all the time. So you can go with SRSS only, but make sure that the modes are very, very distinct, which we are already doing anyway, but that's the thing. All right.
When we use it, sir, like for a live example, is there any live example, sir?
जहां पे आपका geometry बैठ नहीं रहा है,
Okay.
when it is not possible at all to change certain things, there are certain architectural constraints, there are some other constraints, there are some maybe some site constraints. Okay, there are some other kind of a problem is there. So that places we can use CQC. So that ANSYS video, if you watch, it will be even more clear to you. ANSYS software, The developer has given one video on CQC and SRSS. I'll share that link with you guys.
Okay.
Okay, thank you, sir.
All right. So somebody please read it from simplified method of analysis of buildings, Chandresh.
Regular buildings may be analyzed as a system of masses lumped at the floor levels, with each mass having 1 degree of freedom, that of lateral displacement in the direction under consideration. In such a case, the following expressions shall hold in the computation of the various quantities. A. Model mass. Model mass Mk of mode K is given by. Sir, I have to read this one
No.
formula.
You can proceed for formula. You don't need to read.
Okay, sir. So B, mass mode participation factor. Mode participation factor Pk of mode K is given by like this, and design lateral force at each floor in each mode. Peak lateral force Q K at floor I in mode K is given by, where AK design horizontal acceleration spectrum value as per 6.4.2 using natural period of oscillation Tk of mode K obtained from dynamic analysis. D. Story shear force in each mode. Peak shear force VIK acting in story I in mode K is given by like this formula. E. Story shear force due sir, wait, sir. Story shear force due to all mode consider peak story shear force Vi in story I due to all modes consider shall be obtained by combining those due to each mode in accordance with 7.7.5.3. F. Lateral force at each story due to all mode considered. Design lateral force F. Sir, it is not visible, sir. Can you, sir, F roof, I think. F roof at roof level and Fi at level of floor I shall be obtained as like this formula. And 7.8 torsion. Sir, I have to read or I have to wait, sir.
You can read. You can read.
Provisions shall be made in all buildings for increasing in shear force on the lateral force resisting element resulting from twisting about the vertical axis of the building, arising due to eccentricity between the center of mass and the center of resistance at the floor levels. The design force calculated as in 7.6 and 7.5.5 shall be applied at the displaced center of mass so as to cause displaced center of mass and mass of resistance. 7
Okay.
point.
Okay, that's it. So torsion, what is the reason of torsion? We all know that has been, described over here, and there are different other things, story shear forces of each mode as a design lateral forces, modal participation factors. So all these things are being done by the software automatically in the backend, and it is giving us the result by default, like whatever the input we are giving on the basis of that. So these are just the expressions of those modal related areas. So if somebody is interested to, check how the modal mass participation software is giving us. So these 2 pages are the area that you need to investigate upon. Okay. Now the design eccentricity, which is less basically you all know about the 5% eccentricity. So these things needs to be read by somebody else. I'd be asking someone to read it out. I think Ashish can read.
Design eccentricity. While performing structure analysis by the systemic coefficient method of response spectrum method, the design eccentricity EDI to be used at floor I shall be taken as EDI 1.5 ESI plus 0.05 BI, ESI minus 0.05 BI, whichever gives the more severe effect on lateral force resisting elements. Where ESI is equal to static eccentricity at floor I, uh, distance between center of mass and center of resistance, and DI is equal to floor plan dimension of floor I perpendicular to the direction of force. The factor 1.5 represents dynamic amplification factor, and 0.05 represents the extent of accidental eccentricity. The above amplification of 1.5 need not to be used when performing structure analysis by the time history method.
Okay, so this amplification is only allowed for response spectrum method. Okay. Next, somebody else. I think Manoranjan.
Yes, sir. One. Frame
Yes.
building with unreinforced masonry infill wall. In RC building with movement resisting frame and unreinforced masonry URM infill wall. Vibration of story stiffness and story strength shall be explained building considering in plane stiffness and strength of URM infill wall. If story stiffness and strength vibration along the height of the building render it to be irregular as per table 6, the irregularities shall be corrected specially in seismic zone 3, 4, and 5. The estimation of in-plane stiffness and strength of URM infill walls shall be based on provision given hereunder. The modulus of elasticity EM in MPa of masonry infill wall sol has been taken up EM equals to 550 FM, where FM is the compressive strength of the masonry prism in MPa obtained as per IS 1905 or given by expression. URM infill wall shall be modeled by using equivalent diagonal strut as follow. End of diagonal strut shall be considered to be pin joint of RC frame, and for URM infill wall without any opening with WDS of equivalent diagonal strut, see figure 7 shall be taken as where EM and EFF are the moduli of elasticity of the material of URM infill of and RC MRF. I see the moment of inertia of the adjoining column T, the thickness of infill wall, and theta angle theta is the angle of diagonal strut with the horizontal. For URM infill wall with opening, no reduction in strut which is required, and thickness of the equivalent diagonal strut shall be taken as thickness T of your original URM infill wall, provided H by T is less than 12 and L by T is less than 12. Whereas as the clear height of URM infill wall between the top beam and bottom floor slab, and L clear length of the URM infill wall between the vertical RC element, column wall, or combination therefore between which it span. RC frame building with open story. RC moment resisting frame building which have open story at any level, due to discontinuation of unreinforced masonry URM infill wall or structure wall are known to have flexible and weak story as per table 6. In such buildings, suitable measures shall be adopted, which increase both stiffness and strength to be required level in the open story and the story below. This measure shall be taken along both plane direction as per requirements laid down uh, under 7.10.2 to 7.10.4. This this said increase may be achieved by providing measure like RC structure wall or bridge frame in selected bay of the building.
Next person.
When the RC
Next person. Wait. 7.10.2.
When the RC structural walls are provided, they shall be A. Founded on properly designed foundation, B. Continuous previely over the full height of the building, and C. Connected connected preferably to moment resistant frame of the building. Then 7.10.3. When the RC structural wall are provided, they shall be designed such that the building does not have a additional torsion irregularity in the plan than that already present in the building. In the assessing this, lateral stiffness shall be included of the element that resist lateral action at all levels of the building. B. Lateral stiffness in the open story is less than 80% of the story above. And C. Lateral strength of the open story is less than 90% of the of in the story above. That means the stiffness irregularity, right, soft story. Then 7.10.4. When the RC structural wall are provided, the RC structural wall plan density PSW of the building shall be at least 2% along each principal direction in the seismic zone 3, 4, and 5. These walls, these, uh, these walls shall be well distributed in the plan of the building along each plan direction. RC structural wall of the measure can be adopted even in regular building that do not have open story. 7.10.5 RC structural wall in a building located in seismic zone 3, 4, and 5 shall be designed and detailing to completely with the all requirements of the IS 13920.
Okay.
Deformation.
Okay. So deformation, some next person can read.
Deformation. Deformation of RC buildings shall be obtained from structural analysis using a structural model based on section properties given in 6.4.3. 7.11.1. Story drift limitation. Story drift in any story shall not exceed 0.004 times the story height under the action of design base of shear BB with no load factors mentioned in 6.3, that is, with partial safety factor for all loads taken as 1. Displacement estimates obtained from dynamic analysis methods shall not be scaled as given in 7.7.3. Deformation capability of non-seismic members. For buildings located in seismic zones 3, 4, and 5, it shall be ensured that structural components that are not a part of seismic force resisting system in considered direction of ground motion but are monolithically connected do not lose their vertical load carrying capacity under induced net stress resultants, including additional bending moments and shear forces resulting from story deformations equal to R times story displacements calculated as per 7.11.1, where R is specified in table 9. Separation between adjacent units. Two adjacent buildings or two adjacent units of the same building with separation joint between them shall be separated by a distance equal to R times sum of story displacements delta 1 and delta 2 calculated as per 7.11.1 of the two buildings or two units of the same building to avoid pounding as the two buildings or two units of the same building oscillate towards each other. When floor levels of the adjacent units of a building or buildings are at the same level, the separation distance shall be calculated as R1 delta 1 plus R2 delta 2, where R1 and delta 1 correspond to building 1 and R2 and delta 2 to building 2.
Okay. So,
You said
okay, thank you. So next, it is basically about the pounding effect. So expansion joint, whatever you are giving, that needs to be set in such a way that one building should not fall on another one during the deflection or deformations. So that particular things that is being told. So adjacent units separation is being followed by this formula. And also story drift limitation, this 0.004, we all know that. So now next person can read the
Can you explain the
miscellaneous.
7.11.2?
7.11.2 deformation capability of non-seismic members. So for buildings located in zone 3, 4, and 5, it shall be ensured the structural components that are not a part of seismic resisting system is in considered direction of ground motion but are monolithically connected do not lose their vertical load carrying capacity under the induced net stress resultants, including additional bending moment, shear force resulting from story deformation equal to R times story displacement, calculated in 7.1.1, where R is specified in this. So whatever you are doing it as a non-ductile or non-seismic elements, in case of, let's say, structural wall system, if there are any columns, so that column moment also you need to distribute to some other elements so that it should be out of danger. So we are not designing that particular moments for that columns, which are not actually our lateral force resisting element, but still certain moments would be induced over there. So it is asking that to downline that moment to somebody else in such a way so that these columns are out of danger. So this is the deformation capability of non-seismic members, specifically in zone 3, 4, and 5.
So like
Okay, so
subcolumn.
like stop columns, like normal columns also, sometimes we do not give them the lateral forces, right? If it is structural wall system, all the structural wall needs to be taken the lateral forces. So that's what it is saying, that monolithically connected, no, so certain amount of things would be there. So it should not lose their vertical load carrying capacity under the induced net stress resultants, including additional bending moment and shear forces resulting from story deformations equal to R times of the displacement. Okay, so that is basically a part of, soft story, and all these things also you need to
So
check properly.
so
So
it should
story,
not fail in under axial load.
the axial load carrying capacity, it should not lose
Yeah.
for this induced stress or extra bending moments, shear forces. So that extra moment you can channelize to somebody else, then only it will not lose. Okay, so foundations. Who are left? Lopamudra, Renu.
Foundation. Isolated RC footing without tie beams or reinforced street foundation shall not be adopted in buildings tested on soft soil with corrected N value less than 10 in any seismic zone. Use of foundation vulnerable to significant differential settlement due to ground shaking shall be adopted in buildings located in seismic zone 3, 4, and 5. Individual spread footing or pile caps shall be interconnected with ties. See 5.3.4.1 of IS 4326, except when individual spread footing are directly supported on rock in buildings located in seismic zone 4 and 5.
Okay.
All, ti-
Yeah, proceed.
all ties shall be capable of carrying in tension and in compression. An axial force equal to AH by 4 times the larger of the column or pile cap load. In addition to the otherwise computed forces subject to a minimum of 5% of larger of column or pile cap loads. Here AH is as per 6.4.2. Piles shall be designed as constructed to withstand maximum curvature, imposed structural response by earthquake, ground shaking, design of anchorage of piles into the pile cap shall consider combined effects, including that of axial forces due to uplift and bending moments due to fixity to pile caps.
Okay.
7.11.
Okay, so that can be read by somebody, Renu, I think.
7.12.2 cantilever projections. First projection 7.12.2.1 vertical projections. Small size facilities like towers, tanks, parapets, smokestacks, chimneys, and other vertical cantilever projections attached to buildings and projecting vertically above the roof, but not a part of the structural system of the building, shall be designed and checked for stability for 5 times the design horizontal seismic coefficient AH specified in 6.4.2 for that building. In the analysis of the building, the weights of these projecting elements shall be lumped with the roof weight. 7.12.2.2 Horizontal projections. All horizontal projections of buildings like cantilever structural members at the post level or higher or attached to the buildings like brackets, cornices and balconies shall be designed for 5 times the designed vertical coefficient AV specified in 6.4.6 for that building.
Yeah. Wait, wait.
7.12.2.
Next person. I think Sainath, Subama, and Safe is left.
Sir, hello.
Yes.
Sir, can you please explain that the vertical projection that it is telling that 5 times the vertical projections it should be designed for 5 times space like that, na?
The small size facilities like towers, tanks,
Ah,
parapets, smoke stacks, chimneys, and other vertical cantilever projection attached to the buildings and projecting vertically above the roof, but not a part of the structural system of the building, shall be designed and checked for stability of for 5 times of the design horizontal seismic coefficient AH specified in 6.4.2 for that building. In the analysis of the building, weights of this projecting element shall be lumped with the roof weight. Why it is asking? Because during the time of earthquake, what happens, that extra projection whatever is going beyond roof is basically giving certain lumped mass which can take the roof also along with it. So it is basically asking to check with the 5 times of age value and take that particular weight in the roof weight only. So that sort of situation is not coming in our way anyway. If some chimneys or smokestacks are there, so these tanks are not actually the tanks that we are doing. Okay, so that is basically the OHT that we are doing is a part of our structures only. It is basically the non-structural part. Okay, so chimneys or something like that. Sometimes what happens on top of the roof also people put some steel pipes or steel rods, and on top of that they put the tank. Say those kind of situation, if it is there, which is like a extra projection too much, then you can go for this kind of analysis. But unnecessarily for normal projects, it is mostly this kind of scenario doesn't come for us. Towers means the mobile towers. Have you seen the mobile towers? It put sometime it's being put in the top of some roof. So in those kind of situations, definitely you need to, because this is the height of that projection is huge. Okay, so for chimneys also, the height of the projection is huge. So those kind of cases, if it is there, then only this clause will be valid. Understood?
Hello, sir.
Yes.
Sir, in clause number 7.9, it has specified that the strength and stiffness of infill wall has to be considered along the height of the building. So the stiffness means we have to model this infill walls also.
Oh, that's what we have already taken that in the time period, no, in the static time period. So the stiffness is already considered inside the time period itself. Since we are not modeling, that's why you are doing static analysis. Otherwise, that is not required only.
Sir, sometimes, but to capture the effect, for example, Maiban walls and all.
Maiban walls we model. Maiban
Yes.
walls we model sometimes, most of the times actually. So Maiban walls is a separate thing, but for normal infill panels, which are like block work or brick wall, so those things you can model it. There is no problem in it. But problem is this, that the brick and block property is not fixed during the time of design. It gets fixed much later once the site is commenced and procurement gets started. So exact loading exact property of that particular material is very difficult to get it. So that's why we are just following the density, and we are calculate the load and put it on the beam. We couldn't model that because of that property issue, because masonry property is there in the ETABS, but that property is not, masonry property is not like it is a property from some other code maybe. So we need to check the property whatever is there in our system, like in our state or in our places, what kind of brick we are using, what are the different parameters for that we need to put it in the user defined masonry infill parameters. So that parameters are not possible to get from the site all the time. You will not get it anywhere with any vendors. And by looking at it, it is very difficult. Internet, you will be getting multiple properties for multiple different kind of things. So because of this issue, actually, we are not modeling the brick walls. But my one walls, this is a separate thing. My one wall, we are anyway modeling. So for that, it is taken already, the stiffness also. Okay, so once we are modeling my one wall, we are not considering any load on top of the beam if there is no wall. So since we are modeling it, so that way. Yes, Ashish, she was saying something. Yeah.
No, sir, it was by default.
Okay.
By mistake.
So, Safe, you can read this 7.12.2.3.
Okay. The increased design forces specified in 7.12.2.1 and 7.12.2.2 are only for designing the projecting parts and their connections with the main structures and not for the design of the main structure. Clause number 7.12.3, compound walls. Compound walls shall be designed for the design horizontal coefficient AH of 1.25Z, that is AH calculated using 6.4.2 with I is equal 1, R is equal 1 and SA by G is equal 2.5.
Okay.
And clause number 7.12.4, connections between parts. All small items and objects of a building shall be tied to the building or to each other to act as single unit, except those between the separation joints and seismic joints. These connections shall be made capable of transmitting the forces induced in them, but not less than 0.05 times weight of total dead and imposed load reactions. Frictional resistance shall not be relied upon in these calculations.
Okay, so Annex D, somebody else. Subhama can read Annex D.
Sir,
Sir,
Huh.
sir, can you explain compound wall?
Compound wall kya explain karna? Oh, it's a different structure, right? Whenever you will be doing that, follow that SA by G if you want to do the earthquake analysis for compound wall.
Sir,
Model
hello,
it,
sir.
model it in this tabs, and you just assign the age value in that I equal to 1, R equal to 1, SA by G equal to 2.5, and you H of 1.25 of Z, horizontal coefficient, that has to be there.
Sir, is it similar to shear wall, sir?
No. Compound wall is like boundary wall.
Okay.
Sir, hello,
But
sir.
for this, I think SA by G, because it's constant, we have to put it manually, I guess. Like define the
Yes.
function.
Yeah, user defined you need to do.
Then why we take SMLA as a maximum for compound walls? And the AH value is also 1.25. 1.25 of Z, sir.
2.5 is maximum SA by G.
Yes,
right?
sir.
So that, and R equal to 1 we are taking. So anyway, it is like 1, 1. 1 by 1. So it is 1 only. So just 2.5 only we are taking.
Okay.
The IH formula, if you check, I by R, SA by G, Z by 2. Okay, so Z is basically 1.25 times of Z. So the zone factor you are increasing because it is a small structure and we are taking it completely brittle. There is no, ductility. So in that case, definitely base shear we need more. So that's why SA by G is maximum.
Okay.
So there is
Sir,
no ductile clause. That's why R equal to 1.
Yes, sir.
As long as R will go up, the ductility will be more. So it's a small structure, right? Just a line like boundary. So boundary wall be hill like this. It's not realistic, right? That has to be brittle. It is not having any modal behavior. It is not having any, this kind of a thing. It's just the earthquake is coming, it should stand. Okay, and the earthquake will, that's what, like earthquake will not be that much predominant also for boundary wall, because the height itself is not too much. So even if you are taking that, then this is the thing. You take it as a full brittle or full forces you consider. So that's why they have made R equal to 1. So there is no reduction.
Sir, hello, sir. So in this horizontal projections, they have defined that these balconies and this, sir, above this compound one only.
This
Yes,
one,
yes.
na?
Yes. So they have in brackets, they have like brackets, cornices, and balconies shall be designed for 5 times the design vertical coefficient AV. So is that
No, this is for the this is for, again, if the balcony is having too much of projection and there is no backspan, in that case you can take this. But once you will have the backspan, it doesn't have any requirement of this. But yes, 5 times of AV is also too much.
Too much.
So balconies, hardly some projection we keep, right? 1 meter, 1.5 meter, 2 meter maximum. If it is 5-6 meter, then you need to think in a different manner. So that time it's not a balcony anymore, it's a cantilever projection only. So that's the thing. So it's like all these things are based upon judgment that you should put. 5 times you do it, you will not be able to construct that at site. It's not feasible.
Yes, sir.
So that feasibility also you need to take, that how much projection. They have just said horizontal projection. How much, till what level? Have they given any length? No. Now it's up to you. So this is just the 1 meter projection. Do you think 5 times of AV will govern?
No, sir.
So it is just that way. You need to check that particular scenario, what is actually there, and you need to take the call. So balcony can be between 1 meter also, balcony can be in till 3 meter, 5 meter also. So till how much, that should be specified if the code is wanting to guide us in that way. But that is not mentioned over here. So you need to take a call here, that how much we should go with that, and how, anyway 1.5 times we are taking the backspan. So automatically, if the backspan is there, automatically this will not govern in the vertical earthquake. Whenever it will come, this will act as a monolithic action. And the reinforcement also put in such a way that it is 1.5 times extra than it is coming on top of 1.5 times, which is like backspan 1.5 times length, and then the reinforcement is also 1.5 times extra. So on top of that, again, taking 5 times of extra AV, it is not required for smaller projections. For bigger projection, maybe yes. That is the thing. So everywhere code has given certain things, but you need to study the feasibility and you need to study the realistic approach behind it. That's the main thing. What else? Yeah. So Subhama, you can read this.
Annex D, MSK 1964 intensity scale. The following description shall be applicable. A. Types of structures, buildings. Type A, building infill stone, rural structures, and unburned brick houses, clay houses. And type B, ordinary brick buildings, buildings of large block, and prefabricated type, half timbered structures, buildings in natural heaven stone. Type C, reinforced building, well-built wooden structures. And B, definition of quantity. Single and few is about 5%. If it's many, about 50%, and most about 75%. Classifications of damage to buildings.
Okay, so these are basically not required to read. It is basically what is slight damage, moderate damage. It's a definition actually. There is nothing to understand here. What is the grade 4 destructions? What is the grade 5 destructions? What is the grade 3 destructions? So different damage intensity that they have given over here, and they have classified the damage grades on the basis of that. So you can read from MSK intensity scale.
MSK intensity scale. The following introductory letters, first, second, and third, have been used throughout the intensity scale. 1 to 12, describing the following: persons and surroundings, and 2, structures of all kinds, and 3, nature. Not noticeable. The intensity of the vibration is below the limit of sensibility. That the tremor is detected and recorded by seismograph only. Second, scarcely noticeable, very slight. Vibration is felt only by individual people at rest in houses, especially on upper floors of buildings. Weak and partial observed. The earthquake is felt indoors by a few people, outdoor only in favorable circumstances. The vibration is like that due to the passing of a light truck. Attentive observers notice a slight swinging of hanging objects.
Okay, wait.
Largely
So wait. Now this Sainath, you can start from largely observed.
Largely observed. The earthquake is felt indoors by many people, outdoors by few. Here and there, people awake, but no one is frightened. The vibration is like that due to the passing of a heavily loaded truck. Windows, doors, and dishes rattle, floors and walls crack. Furniture begins to shake, and hanging objects swing slightly. Liquid in open vessels are slightly disturbed. In standing motor cars, the shock is noticeable. Fifth point, awakening. The earthquake is felt by indoors by all. Indoors,
No, I think you are reading from your screen, right?
yes, sir.
Yeah, please read.
Outdoors by many people awake. A few run outdoors. Animals become uneasy. Buildings tremble throughout. Hanging objects swing considerably. Pictures knock against walls or swing out of the place. Occasionally, pendulum clock stops and unstable objects overturn and shift. Open doors and windows are thrust open and slam back again. Liquid spills in small amounts from well-opened containers. The sensation of vibration is like that due to heavy objects falling inside the buildings. Slightly damages in buildings of type A are possible. Slight waves of on standing water, sometimes changes in flow of springs. Next, sixth point. Sixth point is frightening, felt by most indoor and outdoors. Many people in buildings are frightened and run outdoors. A few persons lose their balance. Domestic animals runs out of their stalls. In few instances, dishes and glassware may break and books fall down. Pictures move. Unstable objects will overturn. Heavy furniture may possibly move and small steeple bells may ring. Damage of grade 1 is sustained in single buildings of type B and in many of type A. Damage in some buildings of type A is of grade 2. Crack width up to 10 mm is possible in wet ground. In mountains, occasional landslips. Change
Okay.
in flow of springs and in level of well water are observed.
Yes, so this is very basic. You can know that this is just the different intensity that they have described over here, and how the earthquake is being felt by the outsiders, and that has been basically described over here. So the code is over. You can read the few of other conditions and few of other different this thing is also there, intensity parameters. So those are also given in the below, so that you can read it out. And tomorrow, in the next class, we'll be having a quick quiz on the uh, this thing on the 1893 code, and then we'll proceed with 16700. Okay, so that is the next code that we'll be start reading. If you have any doubts, meanwhile, read it out and write it down. We'll definitely address those in the next class. Okay, thank you guys, thank you so much for joining.